All right, folks. I was working with a student on this problem, and it's pretty confusing just to understand what the problem's asking you and the setup of it. And so I wanted to see if I was able to get through it in this video and hopefully make some sense out of it. So uh, it doesn't seem initially to be a problem about differential equations, but it's in the middle of a problem set on differential equations. So um, let's give it a shot here. Okay. So it says at any point P in the first quadrant on a curve. So I'm going to draw a curve. We're going to stick a point P on it. At any point P, the tangent intersects the x-axis at point Q. So I'm just going to draw this for illustrations purposes. So there's my tangent. There's my point Q. And it says the distance from point P to the origin is equal to the distance from point P to point Q. So obviously my drawing is not accurate because this is a shorter distance. So let's try to draw it again. We'll do another curve like this. Maybe this tangent line here. Maybe the origin's over here. So we have P, Q, O are saying that that distance is equal to this distance. We want to try to find the equation of the curve in terms of y given that the point 2, 1 lies on the curve. So 2, 1 is somewhere on the curve. But we don't know that 2, 1 really has anything to do with the point P. So I'm just going to wait to use that information until I get a handle on some of the other pieces. So here's what I know. P is an xy point. Therefore, the distance between P and O is the square root of x squared plus y squared. So that makes a nice right triangle. Here's the other thing. Q has to have a y value of 0. So let's just call it q comma 0. And so I know that the distance of PQ has to equal, I guess, q minus x squared, or it doesn't matter. Maybe I'll do x minus q squared plus y squared. And what we know is that those two things at any point are equal. Okay, so if we set those equal to each other, then we know that x squared plus y squared equals x minus q squared plus y squared. Great. And because I can square both sides, so that seems pretty nice. And then if we subtract y squared, we're getting somewhere. And so then we have x squared equals x squared minus 2xq plus q squared. We can subtract x squared from both sides and add 2xq. So 2xq is equal to q squared. Or I guess if we wanted to factor it, I'm not 100% sure where we're going, but if I wanted to factor it from before, I could say 0 equals q times q minus 2x. So our two solutions would be that q is equal to 0 or q is equal to 2x. Let's just see. I don't even know if we're going to use that. What else do we know about q? We know it's where the tangent line intersects the x-axis. So if I want to think about the tangent line, the tangent, I'm going to use point slope form. So I'm going to do y minus y1 equals m, which is the derivative, dy dx times x minus x1. And what I know is that this will always intersect at q. So I can substitute 0, 0 for y and q for x. So 0 minus y1 is dy dx over q minus x1. Okay. Let's see, what can we do here? Well, we know there's two possibilities. Either q equals 0, in which case, obviously, if q equals 0, then it's the origin. So obviously, that's the same distance away. So I think we can substitute in our 2x here. So we get negative y1, which is just, really, it's just standing for the y value at p. So negative y1 is equal to dy dx times 2x minus x1. And I actually think that the x's that I used in my distance formula, I could also put the x1 and the y1 on, because these x's were referring to the distances to a particular point. So I'm just putting x1 and y1. I can just throw them throughout this to be consistent. So I think that where we get to is this. And we'll see if this makes sense. Negative y, I'm just going to write it without the subscripts because they're a little annoying, times x, 2x minus x. So I can separate my variables here. I'm going to divide by y and divide by x and multiply by dx. So I think I end up with something like this. Negative dx over x equals dy over y. Integrate and integrate. And let's see what happens. So I get negative natural log of absolute value of x plus c equals natural log of absolute value of y. I'm going to exponentiate everything. So I get c, dropping the c down in front, c e to the negative natural log of x equals absolute value of y. When you exponentiate that, the negative power can be division. So I have c over absolute value of x equals absolute value of y. And at this point, I think I want to plug in my 2 comma 1. So let's come over here to the bottom left corner of the screen and see what we get. If I plug in 2 comma 1, I get c divided by 2 equals 1, which implies that c is equal to 2. So now I'm looking at it's just 2 over absolute value x equals absolute value of y, which implies that y equals plus or minus 2 over absolute value of x. We can throw out the negative because it told us that we're going to look at the first quadrant right there. So what I'm going to do is take a look at Desmos and see what happens with 2 over absolute value of x. Let's see, can I split you over here? I'm not sure how to switch the screen over. Let me pause, try to figure it out. All right, so I can't get the dang thing to switch over, but I'll show you what I'm seeing here. So after all that work, we ended up with the function y equals 2 over absolute value of x, which in the first quadrant looks just like this. In fact, in the first quadrant, it's equivalent to just y equals 2 over x. And so its derivative is negative 2x to the negative 2. So its tangent line at any given point is y minus the y value, which is just 2 over a, for example, if you have a point A equals m, so negative 2 over a squared times x minus a. This is the tangent line. And what you'll see is if you draw a tangent line, it hits it right here at a certain point Q, and it comes up here at the origin, and this is always an isosceles triangle. I was able to kind of play around with it and see that it always worked out to be isosceles. So this was the solution in general. We had a plus or minus on it. When we restrict it to the first quadrant, we get that right there. And if you go and actually calculate the distances now, you can see that the distance between OP is the square root of x squared plus 2 over x squared. And if you do the distance between PQ, that is using this formula right here. You can see that this tangent line is going to get hit 0 precisely when negative 2 over a is equal to this times x minus a. And so if I divide by negative 2 and multiply by a squared, I get that a equals x minus a. In other words, x is equal to 2a. And so that's the whole idea that I was talking about earlier. And so you can find the distance right there, and it turns out to be the same thing because we're just doing like 2a, like this was the a value that I was using, and this is just 2a minus a squared plus 2 over a squared. And so these end up being exactly the same. So sorry I couldn't figure out how to make the tab switch here. I'll look into doing that. Please comment if there's anything that's confusing, and thank you.